Hello. There was a question in the forums recently about making soft body wheels, and more specifically how they could be made using the RUBE editor. And I've been thinking that I might make a series of videos, or a video occasionally, about specific cases of using RUBE to make something specific, as opposed to tutorials which are very general. So I thought this is a good one to start with, because it's quite specific and it's a little bit involved. As you can see, there's quite a lot of bodies making up this wheel here, and it's also a good candidate for using script because it's kind of a pain in the ass to set up all these joints. If we have a look at the joints here, there's I think there's 18 bodies around the outside of this wheel, and they each have 2 joints holding them in place, so it's kind of a pain to set that up by hand. So this case study will be a little bit advanced in that we are going to write some script to help us do this, but it will be a good case study to look at, I think. So as you can see here, well, you can't really see by looking at this, but we have revolute joints, and we also have wheel joints holding each one of these rim pieces to the central hub in the middle. So I'm just going to close that project completely, and we're going to start from scratch. And first thing I will do is make a ground piece, and make that like this, and that's a static body, so that's our ground. And I will put the cursor at 0, 1. So obviously this video assumes that you've watched the main tutorials, so I'm not going to explain the basic stuff. So we're going to add a circle body and this is going to be the central hub of the wheel, and around the outside of that, let me just place this a little bit more precisely. Around the outside of that we will start adding the rim bodies, and I'll start with the square fixture there and scale this down to size like this, and then vertically something like hold on a second. Let me just scale. I want a little bit more detail when I'm scaling at the moment. Okay, so this piece is going to be one of the rim pieces, and I'm going to try for 18 pieces in total, which should be 20 degrees between each of them. And let's just make this body a static body for now, so it's going to hold in place while we when we run it in the player view. And then I'll select this body as body A and this body second, so that's body B, and I'm going to place a wheel joint between those two. So if I look at this in joints mode, we should see there's a joint here, and by default the axis is 0, 1 vertically. And we look at this in the player view, we should see that because body A is the one that gets the line part of the joint, this little small body that we stuck on can rotate like a wheel, as if it was a wheel on the car, and it can slide up and down on this position, and when it's released it will tend to go back to its kind of resting position there. So we want a whole lot of these things joined together. So let's select this body. Oh, wait a minute. First we'll put the cursor here, then we'll select this body and we will duplicate it, and rotate it, and I'm going to rotate it 20 degrees to here, and then I'm also going to place the cursor at this point between them, and I will then select this one as body A, this one as body B, and place between them a revolute joint. Now if I look at the joints mode here, we should actually see 3 joints, because what happens when you duplicate a body is that all the joints that are part of that body also get duplicated. So we actually have 2 joints on top of each other, and we can see from this red line that the wheel joint that is joining body A to this new body is it's off center. So if we run this now, it will be all it's impossible to satisfy those constraints. So one thing we're going to have to do is select the joint that we duplicated, and we're going to have to rotate. Oh, okay, I've got the cursor there. Let me just put the cursor back to here. Now I can rotate that second joint that was duplicated in the same way so that it places its local anchor in the middle of that body. And we are not quite finished, because you can see that the axis is still 0, 1, and the vertical axis, that is. So we also need to rotate the axis of that joint by 20 degrees as well, like this. And it should be better now if we run this. So we can see that we have the beginnings of a link of chains, a chain of links, and they both, each individual piece moves towards the center of the wheel like this. And while we're here, why not let's make these joints collide connected so that they don't push through the hub inside like this. So I'll select these 2 joints and make them collide connected true. So if we run that now I can't pull those joints inside the hub. Okay, so this is the beginning of our chain. So this is like the 2 prototype links. Now this is where it becomes a bit of a pain in the butt to do this over and over again, because what we need to do, I'll just go through the steps that we would need to do if we were doing it manually. We'd need to select this body, duplicate it, rotate it 20 degrees and place it there, and then we need to go into joints mode, rotate the local anchor A of the wheel joint here, and then rotate the axis of that joint as well. And one thing we'll also notice is that the revolute joint that was duplicated will also need to have its body A's local anchor moved over here. Sorry, big button. The problem now is that this revolute joint has body A is still this body on the far left, but we want body A for this joint to be the second one now. So to fix that problem, we would select that joint, and we would select that body A should be this body. So now when we look at that, we should see no conflicts, and when we run it we should find that it's okay. So that's continuing our chain. So it's not too many steps, there's sort of 3 or 4 steps that you need to do, but you need to do it another 16 times to make the full chain, which is quite a number of times if you want to make more than one of these wheels. And you'll find that often you'll get halfway around the chain and you'll think, oh wait a minute, maybe I should put this joint a little bit more inside or outside or something like that. So then you kind of have to go back and change everything that you've done. So what we're going to do from this point is, instead of doing everything manually, we'll make a script to do it automatically for us, so that if we want to come back and make changes later, then we can just run the script and apply those changes around the whole outside of the wheel without having to do everything ourselves. So I'm just going to delete this body that we made afresh here, and I'm going to open up my script panel, and I'm going to start typing in some script. And this is not a trivial script. This is going to take about 20 lines of code, but I'll just step through it piece by piece, and it should be not too complicated to understand. First thing we're going to rely on for the script is that the cursor is going to be in the middle of the hub here, which it is now, and we also will rely on having the right hand side body selected. So if you remember from just before, when we did everything manually, the first step is to duplicate this body. So we'll so we first need to get a reference to this body. So this SB function is a short form of get selected bodies, and we want to get the first selected body. So this assumes that we have something selected. I'm not going to put any error checks in here. And then we do this body NB. So NB stands for new body, and we're going to duplicate the body that we have selected, and then we're going to rotate it, rotate the new body. And if you look at the script reference, you'll see that the next two parameters that are given to the rotate function are which should be the center of rotation. So should it be the cursor, which is 0, as I'm going to use, or the center of the selection? In this case, so we want to rotate around the cursor, and we want to rotate by 20 degrees, actually minus 20, I'm afraid. So minus 20 degrees, and this should be given in radians. So we can use the degrees to radians function. This is just the convenience function to convert degrees to radians. That's dr. And let's just run this now and see what that gives us so far. So we've just done the first step of what we were doing manually. If we look at this in joints mode, we'll see all those joints are a little bit out of whack at the moment, but that's the next step. So I'll just undo that. So the next thing that we need to do is we've got two joints that we need to fix. There's a wheel joint here, and there's the revolute joint that connects the two chain links. So what I'm going to do is I'm going to label these so that we can identify them. And I'm going to call the two wheel joints wheel, and I'm going to call the revolute joint rev, just for short. And then if I go back to my script, what we're going to do is make use of a function called getJoints, which lets us get a reference to all the joints that are on a certain body. And in this case, we're going to use the new body getJoints. So this returns an array of every joint attached to the body that we just newly duplicated. And we're going to loop over all of those joints, and like this. And we'll get a reference to the joint j equals j's I. Okay, so now we have this j variable will be these two joints. We're going to loop over just these two joints here, and we're expecting that one of them is going to be called wheel and one of them is going to be called revolute. So if this joint's name is wheel, that means we're dealing with the wheel joint that we duplicated, and we can do something. Or if its name is rev, then it's the revolute joint. And what did we need to do with the wheel joint? We needed to move the anchor A, and we needed to rotate the axis. So that's two things, so we'll need a little bit of a bracketing here. Let's space these out. Okay, so we need to do set local anchor A, because remember when we made these first two bodies, anchor A, body A was the one on the left, body B was the one on the right. So we'll need to update the local anchor A of the wheel joint. Okay, so what do we need to set it to? Well, when we duplicate this body and rotate it, we want to set the anchor in terms of the hub body to be the center of where the new body is. So it's going to get a little bit long, this line, but basically we want to find body A of the joint, which is the hub in the middle. Get body A, and we want to find the position of this new body that we created in the local space of that body. So that's get local point new body's position. So that will set this joint to be the right anchor position. So let's just check if we got that right. If with empty statement, that's not an error, come on. I guess AngelScript doesn't like that, huh? Okay, let's try this. Make sure we have that body selected, yes. Okay, so this time when we run the script, we'll see that the anchors of the wheel joint are both in the right place. So that's good. The axis is still not right, so let's change that next. So that's going to be j set local axis, and what we want to do is make it, the previous axis needs to be rotated by 20. So let's do get local axis. This will give us the local axis as it was immediately after we duplicated, and we need to rotate that by 20 degrees. And once again, we'll need to use this dr function to get everything in terms of radians. So here we have the same angle here. I'm just going to make this a variable, float angle minus, just so that it's a little bit easier to change as one number later, and it's a little bit more descriptive as well. Okay, so let's run this and see what we get with that. Alright, now we can see that the joint axis has been rotated by 20 degrees as well. Okay, last thing we need to do is change the body A of the revolute joint to be the previous body. So that's going to be in this part here. So if the joint that we're looking at is the revolute joint, then we're going to do set body A to be the previous body, which was the one that we had selected when we duplicated it. So hopefully this makes sense. I'm just going to put B because that's the body that we originally had selected. So let's run that, and that looks pretty good. Let's just check it in the player view. Yes, everything looks fine there. Yep, I think it's working good. So we need to do that a total of 16 times to make the full revolution, and we can put this all in a loop as long as we make sure that we set then, because I'll show you why we need to put it in a loop, why we need to set the bodies correctly. So if I have this selected and I run it 4 times, we're just going to plop everything onto the same place because we still have this body selected. So what we need to do is, when we make our loop, let's say reps, so 16 times, right? So everything that's inside here is going to be in a loop. Alright, and this is my finished closing of my loop here. And one important thing that we're going to need to do is we have to say that B is now the newly duplicated body, so that the loop continues by selecting the newly made body that we created, so that this time when we run the script we should see that it makes a full revolution, almost a full revolution, because we're still missing the final revolute joint between the last 2 links. But let's just check how this runs, and seems like everything's okay. And the nice thing about being in script is we can undo and redo this, and we can do things like you might like to adjust pieces of the body like this. This is obviously a very rough example, but now if I run the script we'll see that because the script is working with whatever we had selected, we can change it multiple times and we don't have to go through all that process of setting up those joints again. So this is the beauty of making things scriptable. It's kind of a little bit of work. See, we did quite a bit of typing to get that set up, but in the long run it will save you a lot of time, I think, and you can put it into one of these action menu items here to be easier managed than typing into the script panel. Okay, so let's put these back, and let's close off this last link here. And one way you can do that quite easily is just by selecting the last joint and duplicating it, and when you duplicate it you'll be automatically in this mode where you can move it around. But what I'm going to do here is just hit escape to exit that mode. So there's 2 joints on top of each other here now, and the one that's selected is the one that I just created afresh, the newly created one. So what I'm going to do here is I'm going to select, I want to change both body A and body B of this joint to be these two bodies here, so that the joint will move to this position. And we just do that by changing body B. It's better to change body B first, because body B is already this one at the moment, if that makes sense. So we should do body B and then body A, and then we'll see that the joint has moved to here and we have a full link and everything's nice. One thing I noticed when I was preparing for this video is that the position that you place the revolute joint in can make the wheel a lot more believable. Let's just make this to a dynamic body so I can show you what I mean. Because we have a problem in that as each of these wheel tread, the rim pieces move in towards the center, they have no choice but to move towards each other as well, because the distance obviously gets more narrow as they move towards the middle. So you see them kind of bunching up like this. It seems to be unavoidable with the revolute joint in this position. But I found that if you move the revolute joint outward a little bit, or even quite a lot more outward, it helps a lot. So just show you what I mean by that. So this is the great thing about scripts. When you discover some problem like that, it becomes quite a bit easier to fix it. So what I'm going to do here is I'm just going to move this revolute joint out, and I found that it works quite nicely when it's sort of about there. Now I just run my script again, and we have a whole lot more joints, and this time the revolute joints are on the outside. See, that was easy, wasn't it? And if I duplicate that and I do my little trick with the bodies again to close off the loop, now we should see, let's make this static, dynamic again. Where's it falling through? Oh, it's starting right on the middle. Okay, let's move our ground downwards a little bit. No, not that one. Let's move this downward. Okay. Right, so you can see now that as the pieces of the wheel move towards the center, it's not quite as bad as before, in that they don't bunch up so much, because the position of the revolute joint is not pulling them inwards towards each other as much. We'll still obviously have that problem if we squash it right down like that. And you'll notice that it's spinning around of its own accord, but that, I think, it just seems to be an unavoidable issue with floating point precision when you make a closed loop of joints. As soon as you take one of these links of the chain away, it's not a closed loop anymore, so it doesn't have that problem. But you can fix it by adding a little bit of damping to these bodies, angular damping or linear damping. Alright, so we've pretty much covered the main topic that I wanted to cover. But while we're here, I'll just go a little bit further and make a car, and we'll do that whole monster truck sort of thing, and then we'll finish the video there. So obviously, now that we've got one of these things set up, we can just select all those bodies and duplicate them like that. Actually, before I do that, I will make a body for the car. Hey, let's make a different kind of car. Let's make it like a 6-wheel car. So now we have body A, body B, and I'll put the center of the wheel joint here, and I'll select these two bodies and I'll do add wheel joint. So now we'll see we have a joint in the middle, and at this point then we can do that copy. It makes it a little bit easier because the joint is already in place. So now if I do Shift D to copy and make a couple more wheels, in joints mode we'll see that those positions are off, but we can fix it like this. And this one also, we need to move the anchor A position, this one, to be where the wheel center should be. This is anchor A of the joint, as you can see by the green line. And the joint axis for those joints is vertical already, so we can just leave it like that. And let's see what that looks like. Okay, we have a bit of an issue with the masses of these bodies now. Oops. Yeah. Now we can see that because we've put something heavy on top, we are getting a huge squash down, and another problem is that these bodies are colliding with each other. So we can fix that by setting up some collision mask, collision filter settings, and changing the masses of the rim pieces here. So first thing we'll do is switch to fixtures mode, and we'll start giving things some categories. So I'm going to call bit plane 1, this will be ground. Bit plane 2, I'm going to call that the main chassis of the car. Bit plane 3 will be hub. Bit plane 4 will be, let's call this rim. So this one that we have selected is a chassis, and we want that to collide with the ground and the hubs, but not the rims, right? So that's the important one. We don't want it to collide with the rims. And everything else should be okay to run like that, I think. So let's see. Why didn't that work? Oh, we didn't give everything categories. Okay, so we have to give these categories. So these are hubs. Typically you'll only have one category for each fixture. This one here is ground, that's already set. So we needed to give the rims categories. So let's deselect all the other pieces. And this is a rim and it's not a ground. Okay, let's try that again. Okay, that looks better. Let's try now improving the situation with the wheels rubbing on the ground, or should I say getting squished up and from the ground. We've got two problems here. It looks like the friction is way too low, and also the density of these fixtures at the bottom are way too low as well. So we already have them selected, so let's make their density about 5 times higher, and we'll set the friction of these to 1, and I'll make the ground friction let's just make it 1 for now, and that means that the wheels are not going to get squashed up so much. They still will get squashed up a little bit. Another thing you can do to improve that is, if you don't really need these to be so squashable, you can just make these fixtures a little bit bigger. So Let's make these like this. Now, because the hubs and the rim pieces are collidable, the rim pieces can't really get squashed up too much anyway. It seems a little bit silly how the whole chassis of the car can squish down into the ground like that. So one thing you can do to fix that is to select this body and add another fixture to it, and it doesn't really matter really too much how big it is, because we're going to select this as a fixture and make the density 0. And I just want to demonstrate what that means. We can make this humongous, and even if we put it way over here, it doesn't affect the center of mass of this structure as a whole. Oh, well, it's colliding, but if it wasn't colliding with something, let's put it over here. So logically that might look strange, but remember, if we set the density of this to 0, it makes no difference to anything as far as weight is concerned. So why did we put it there? Well, we put it there so that we could make it like this, and then we could make it as a collider to stop the hub pieces from moving up too far. So we need to also give this a category, so we'll call this hub limiter, and we'll say that it collides with nothing at all except for hubs. Hopefully that makes sense. It's a hub limiter, it collides with the hubs and nothing else. And it has no mass, so it's not going to affect any of the physics behavior that we already had there. The point is that when I grab this and squish it down, it still collides, because these joints, I forgot, these should be made collide connected should be true on these, to make sure that they can actually collide with fixtures in the chassis. Except we don't want them to collide with the body itself. We only want them to collide with this hub collider. So you can see there's quite a bit going on here, even in this fairly simple example. So I'll go back to here and I'll select the chassis, and I'll say I do not want the chassis to collide with hubs. So I'll remove this bit flag. Alright, now we've got it working. So we have a car body that doesn't collide with the hubs, but it does collide with this collider thingy. And then you can set about making your car a little bit more believable. Make it look faster. Oh, that looks speedy. Doesn't really matter where these points are because they don't play into it much. Okay, and we can also, just as a test to see how this would work in a game kind of situation, we can also make some ground here. Like that, yep. And give it a little quick test. Like that. And this also lets you adjust things like how fast and how strong these motor joints here should be. So I'm going to give them enable motor true. Max motor torque is 100, and we'll make them spin at 1 revolution per second clockwise. So that's 360 degrees per second, and let's see what that gets us. It gets us a bit of a problem. So you'll find that once again, because it's a closed system of links, it has a bit of trouble keeping everything together. So you don't want to have too many links in this thing, and you don't want to make them too light, and you don't want to spin them too fast. So that's the other problem that we're coming across here. So to be a bit more reasonable, I'll bring that to half a revolution per second, and that should be a fair bit more reasonable. Okay, and then you can adjust things like the frequency and the damping for those joints as well. And they seem a bit hard, so we could do something like and they seem a bit bouncy, so I'll make the damping a little bit higher, and I'll let them come upwards a little bit more. Just move my collider up, and what else can we do? The bounciness or the softness of the wheels seems about right, but if you wanted to make the tires seem stiffer, you could also set the frequency and damping of these wheel joints in here to be harder or softer, or have more or less damping. I think that's kind of okay at the moment. Okay, now it looks a bit softer, and we're getting more wheels on the ground, less bouncing around. This is kind of weird. Let's make it a bit more like that. And from this point you could be here all day playing around with variables and adjusting things to get it to look how you like. But I'm going to cut this video here, and hopefully this has been a useful example of how you can use script and how you can make soft bodies. So if you have any questions, jump into the forums and let me know. Otherwise, thank you for watching.